In grade 10, you did lots of factoring. Some of the things they add in grade 11 is how you would factor when there's decimals and how you would factor when there is fractions. And it's not too bad, okay? What we want to do is we want to multiply to get rid of those things. If I want to get rid of decimals, I'm going to multiply. If I want to get rid of fractions, I'm going to multiply. Now, these aren't equations, so if you just multiply it by a number, you change what it looks like and you change what it equals. Like if you had 2 and you just decided, I'm going to multiply that by 10, you have 20. That's not what you started with. But a trick that we can do in math, something fancy, it's called doing nothing. It's a very fancy trick. Okay? So the fancy trick for doing nothing in math could be something like this. I'm going to times by 10 and then divide by 10. Ooh, what have I done? Nothing. Okay? Does that make sense that if you times by 10 and divide by 10, you've done nothing? Right? If I times by 3 and divide by 3, I do nothing. Now, dividing by 10 is the same as multiplying by 1/10. Ooh, still nothing. Okay? But in this question, if you do nothing, it's going to help you. So it looks like this. If I would multiply this by 10 and divide it by 10, I could write it, I could even write the dividing by 10 first, then multiply by 10, and then here's my thing that I started with, x squared minus 1.5x plus 0.5. Why would I want to multiply that by 10? Give myself some whole numbers, right? Get rid of those decimals, because probably your decimal times table isn't the best. Non-existent. So if I multiply this 10 through to each thing, I will now have 10x squared minus 15x plus 5. Because multiplying by 10 will just move the decimal place over 1. Can you see now that what we have in brackets is a trinomial with no decimals? So now we can go back to our grade 10 skills and say, how do I factor that? Is there a common factor? Because that's something you check always first. 5. So I'm going to pull out a 5. I would still have 1/10 times 5 now. And I'll put those together in a bit, but just to show you, I'm pulling out a 5, leaving me with 2x squared minus 3x plus 1. How do I multiply 1/10 times 5? How do I multiply fractions? Do you need a common denominator? No. Make 5 over 1. Multiply the tops, multiply the bottoms. You see that I'll get 5 over 10? Yeah. 5 over 10 can be reduced to 1 over 2. I'll do that right away. 1 over 2. And now I'm going to attempt to factor the trinomial. Again, I'm going to think about foiling. I know that this is my first one. I know that this is my last one. This example is one of the easiest ones to factor ever. It is. Because look at your first ones. What is the only possibility to get 2x squared? 2x and x. All right. Now the complicated part was usually here we had more than one choice. What are the only two things that multiply to give you 1? 1 and 1. And are they both going to be positive or both going to be negative? They'll both have to be negative. Because now check, but check the outside. What's the outside? -2 and a negative 1 makes negative 3. Because you have to check the outside and the inside. See, the outside's negative 2, the inside's negative 1. We get negative 3. And we've factored this. So we got what happens in order to factor it is we take out the decimals and stuff at the beginning. That'll give us a fraction in front, which is okay. And then we'll be able to factor the inside. Now, I chose 10 because most people can see to get rid of a decimal place, you can multiply by tens or hundreds to move that decimal place, right? You've learned that in the past. Can you see that we could also multiply by 2? Yeah. Okay. And then divided by 2, it would give you the exact same answer because we got 1/2 in the front in the end anyways. So that's how to deal with decimals. With fractions, which we have here in part B, whoa, I didn't want that to come out. Let's try this one. So in part B, we have a fraction. How do you get rid of a fraction? Multiplying. So what I'm going to do is I'm going to multiply that whole thing by 3, but in order to do nothing, I'm also going to multiply by 1/3, because multiplying by 3 and multiplying by 1/3 does nothing. I don't usually like using the little x's for multiplying, especially when there's x's in the question. You okay if I change those to dots? And now if we distribute the 3, we'll get 1/3 3x squared minus 17x minus 6. Close that bracket. Is there a common factor in that trinomial? No. So that means we have to go to our two binomials. We look at our first one, we look at our last one. And as a strategy over time, you're going to find out it doesn't matter if you look at your first ones first or your last ones first. I always look to see if either of the two are prime numbers, okay, between my first and my last one. Because 6 isn't a prime number. I don't know if it's going to be 2 and 3 or 6 and 1. So that opens it up to some choices. But 3 is a prime number, so the only possibility for my first ones is 3x and x. And it doesn't matter if you write x and 3x or 3x and x. Now you're going to have to do a little bit of mental math to figure out if the 6 should be a 2 and a 3 or a 3 and a 2, because now it'll make a difference. I'm going to just make a new pen. You okay? Just hold on a second here. Fill effects. No, what do I want to do? Oh, maybe I want to line style. No, record. There we go. That's what I want to do. No, 6 might be good. Let's save that. Nice. That'll be good. What that allows us to do is now this pen is a little bit magic. I should probably change the color, but it's magic because like after 6 seconds it just disappears. Yes. Okay. So, because that's nice because 6 seconds should be enough time for us to do some mental math. Okay? If I put 3 here and 2 here, can you see that the outside is 6 and the inside is 3? Does 6 and 3 ever make 17? No.
Also, I can't see it anymore.
So then we try 2 here and 3 here. It makes a difference because now my outside's 9, my inside is 2. Does that ever make 17? No. So what you're going to start to look for, is there a way that I can get 17? My outside should be a 6 here and a 1 here, because then my outside is 18 and my inside is 1. Does 18 and 1 ever make 17? Yes, if you're subtracting. Now to get a negative 17, we would need our 18 to be negative and our 1 to be positive. Whenever you factor to finish, you want to check, does this work out? When I FOIL that out, do I get exactly what I have here? My first ones give me 3x squared. My last ones give me a negative 6. And my outside and inside give me negative 17x. You should always, 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 every time you factor, do that check mentally in your head. In fact, anything you do mathematically, whenever you write the next line, I don't know if you notice it because I do it silently. In my mind, I check. Does this equal what I had in my line above? And you should get in the habit of always checking. I do the next line, does it equal? Yes. Because nothing is more frustrating than doing 10 lines of math work and not checking and getting the wrong answer and find out, oh, now I've made a mistake in one of these lines. So you want to check as you go along. 9, 10, 11, and 18. Are the questions you can do for this one.